Thank you so much, and thanks for having me. Um, and thanks for the introduction. So, I want to talk about why I believe that legacy software is probably not really a problem. I'm Eberhard Wolff. I'm head of architecture with SMACLab. We are a consultancy focusing on digitalization, a freshly founded company about a year old. So, lots of interesting challenges based in Hamburg. So first of all, let's get one thing out of the way. So legacy is a challenge. However, if you are working on a legacy system, even if you don't really feel like it, I would like to congratulate you on working on a legacy system. And the reason why I think that legacy software is actually great is because legacy software does have a business value. If you build some new software, it's not entirely clear what the business value will be. And if you don't achieve product market fit eventually, then you might have a problem and you might never really build something valuable. But legacy software is something that people do use, and you wouldn't be working on it because that is probably old software that isn't really that nice anymore. So if there wasn't any value to it, the organization would just get rid of it. So your job is important if you're working on legacy software. And it's also an interesting challenge. So one of the reasons why I like working with legacy software is because there are so many more difficult decisions to make, and it's just so much more of a challenge. So why legacy software is great? But first of all, let me point out that legacy does have a positive connotation, at least outside IT. So I had a discussion with a native German speaker who said that, well, we should really have a more positive name for legacy software, like heritage or something. But really, if you're a native English speaker, you would agree that legacy is a positive word. So interestingly enough, in IT at least, it became that bad word and that bad thing, even though it's originally a good thing. So what are the advantages of working with legacy systems? Well, what is software development even all about? So is it about code? Well, if you look at the GitHub Scala compiler project, the two most um, the two committers that did most of the changes to the code. One of them is Paul P. And as you can see, he added about 425,000 lines of code, but deleted more than 450,000 lines of code. And the second most important committer to the software did something similar. So those two had a net negative number of lines of code that they wrote. So it's not about the code that we are writing. Deleting code is actually a good thing, as you can see here. And I wrote a blog post not too long ago about AI. But the main point that I made there is that it's not about producing code. Software development is not about producing code. It's rather trying to figure out what you need to build. And the argument that I'm making in that blog post is that for that problem, AI isn't really that helpful. So I would argue that software development is about learning. We learn how to do things better. We learn more about the domain, so we have a better idea about what the business logic should actually be. We learn more about the business case, so we have a better understanding about, again, the business logic and what the business logic should be like. We learn about architecture, how to do architecture. We learn about technologies. I mean, this is also the reason why we are even at conferences like this one. So that is what we are faced with, and learning that stuff and putting it into code, that is what we are mostly concerned with. However, with legacy software, actually, we do know quite a few things. So there is an approach to solve the domain problem that has been implemented. And what is known, therefore, is the domain. We know what domain problem should be solved. We know the business case. We know it's a valid business case because people do care about the software, so it has to have some business value. We know one architecture approach. We know one approach concerning technologies to solve that, and we also know domain experts. So we know the stakeholders for that software. Those are the ones that we talk to, and we also know the users. Those are the ones that use the system that we are working with. This is again different if we have some greenfield project, because with a greenfield project, you might not know the users in advance, if you're unlucky, then there might not even be any users whatsoever. So the advantage that we have is that we know quite a few things, and we also know the weaknesses. And those are probably the reasons why we are working on the legacy software. So we somehow need to improve the legacy system. And one of the reasons why we might need to do that is because of outdated technologies. And another reason might be because it's hard to change. But really, hard to change doesn't matter at all if you don't want to change the software. So really, it's about new requirements. It's not about the fact that the software is hard to change. It's about the problem that we have new requirements, and then it's not great that software is hard to change. So let's go through these reasons why you're working on legacy in more detail. First of all, let's talk about outdated technologies. So is that really a reason why you want to deal with legacy software? And here is something that I keep wondering about, and that at one point I do want to see some calculation about. So if you want to replace a legacy system, then what you're doing is you're starting a software development project. And those software development projects are usually costly, they are high risk. We all know that, the things might be over budget, might be hard to implement, and so on. And it might be less risky and also cheaper to just stick with your technology. And ways to deal with that is to educate developers in the old system. That might take some time, but it might be cost efficient and low risk. So old technology might even be things like, fourth GL languages, Oracle Forms, COBOL, and so on. And if you use this approach that I'm talking about here, then you would get some developers that probably know that technology that you're looking at, and you would need to educate them in the old system, which might take considerable time, month or maybe even a year. But still, this might be more cost efficient than building the system anew, because as I said, that would take a team, and it's also something that is more risky. However, at one point, those technologies that you're using might not get any security updates anymore, and then you might need to migrate the system eventually. And here is a conversation that I had actually more than once. So you're stuck with some old technology, and one of the things that you could do is you could use a cross-compiler and an emulator, or maybe some kind of automated translation. So for example, there are COBOL compilers that cross-compile into Java bytecode. And if you look at the effort that it would take to rewrite a whole system, then you might even build your own solution. And the reason why I think this might be a valid solution is because it's not that risky. It might be cost efficient. And more than once I get a response that says, well, why would you do that? Why on earth would you do that? The software needs to be changeable. So we need to do something else. We need to do something different. We need to somehow create a system that is maintainable. But then it's not about just the outdated technologies. Then it's about something different, right? We want to somehow be able to change the system. Here's also a different thing that I want to talk about. So let's imagine that we have that system with some user interface, some API. We have that old complex architecture, and we might migrate it to a new system where we have the same UI, the same API, but we have a clean architecture. The important point here is that from a user perspective, so someone who is either using the user interface or the API, those two systems are basically the same. So why would anyone support that migration? It's the same system to them. And this is difficult because you need their expertise. So you need the expertise of the business, um, and of the business experts, the domain experts, the users, to understand what needs to be built, what is important, and you also need their political support. So you can try to force them to use some new system, but that's not really the position that you want to be in. So I would argue that really, a system that is hard to change, well, that's only a problem if there are new requirements. The outdated technology is usually not the only driver. Otherwise, this emulation cross-compiler stuff would be the better way. So at the end of the day, it's probably almost always about new requirements and being able to change the system. And therefore, my recommendation would be to provide business value, even if you're dealing with just a technology migration. Because if you just build the system in new, then there is no benefit for domain experts and for users, so they won't support what you're doing. And in this situation, it's great that you do know the business case and the domain experts, because that means that you know who to have a conversation with about the value, what you can do different, where there are advantages. So with a legacy system, there are more advantages even. There is already a system. So, and this is a useful system. So we are just asked to optimize what is going on here. And the existing system is sort of a fallback. So it provides us some freedom to improve and to make things better. But something has to change. So this is why we are talking about migration. And I'm more often than not, I'm asked in a consulting gig for some support concerning a legacy migration. And one of the questions is, so how long will the migration take? And to get some ballpark figure about that, it's interesting to figure out how long the development of the original system took. So let's say it took 10 years, and now the migration should just take 1 year. So that's a factor of 10 faster. So why would it be that much faster? And you can also just let people estimate the time it takes to migrate the system. And this is something that I did. So I had them just estimate the time it takes a month, and we took the Fibonacci numbers, and the result was 89 months. And they basically all agreed on 89 months, which means that there is still some uncertainty, right? Because they couldn't pick a number between 55 and 89, and they couldn't pick a number between 89 and 144. So if it's really 120, they would end up with 89 probably still. But that's not the point. It's about a ballpark figure in that case. And if you think about that, that's roughly 7 years. And you cannot run a project like this and not provide any business value for 7 years. So you need to do it stepwise, and you need to somehow provide business value while the project runs. There is just no way that you can, hide away in some room, have a team separated somewhere, and let it work for 7 years on some project, and then have a big bang migration. So the choice between big bang, where you have that migration from the old system to the new system at a specific point in time, and stepwise, where you add new functionalities, new things, you need to do it stepwise. It's not just about risk, it's also about providing value to users and domain experts. So it's less risk, you can provide value while migrating. And Big Bang might still be an option, but it's probably really for small and simple systems. Those are the ones that I usually that I'm not really asked for any opinion about as a consultant, because I'm usually asked for more complex scenarios. But in those cases, it might be valuable to do it with a Big Bang. There are other reasons why you want to do it stepwise. So a complex system that works has evolved from a simple system that worked. That's a fundamental hypothesis in systems theory, in systematics. And what this means is there is some system that is large and complex. That's the legacy system. And if you want to do a new system and then do a big bang, you're doomed to fail. This is basically what it says, right? You need to somehow have some stepwise approach to that problem. The advantage that you have is you already have an implementation of the business logic. So what does that mean? Well, we could implement the same logic in you. So we could just take whatever it is, the COBOL source code, and just take that code and in a more or less mechanical way translate it into Java or whatever it is that we want to build the new system in. This will probably mean that we have slow development because we need to understand the legacy code, which is probably hard to understand and hard to change because that's the reason why, we don't want to keep it around. It's probably frustrating for that reason. And it seems to me that this is often what IT says. Okay, so here's the old system, here's the new system. Let's build a new system. It should basically be the same thing. It's just about, migrating from COBOL to Java. And the result will be a very complex system and probably new legacy. So in one of the, it was one of the first large project that I've been part of. That was a mainframe migration, and we ended up building a system that was still using the same metaphors and even some ideas from the original paper-based process even before the mainframe was introduced. So we were really stuck to the very old ways of doing things. And of course, the system would be rewritten in Java, and therefore it would be, well, a more modern system. But the thinking and the way the business logic was structured, it was really still as in legacy. And this is a slide that I already presented. So we end up with this problem. For a user, the new and the old system are indistinguishable. So why would they support building the new system? And now we do have an advantage. And the advantage is that we do know the business case. We do know the domain experts. We do know the users. So we can explore the domain, and we can try to implement new and useful business logic. We can ask, okay, so what do users actually like? What is the value of the system? How can we improve the value? And so on and so on. And I want to share with you two success stories or examples. One example was a project that did a stepwise migration to microservices by the book. So I wrote several books about microservices. I took a look at what they were doing in that project, and it was basically a very good approach that they were using. And then at the final day of the review, I had a discussion with the management there and asked the question, okay, great. So you're doing it from a technical perspective, you're doing the right thing, but what's the value to your customer? What's the value to the users of that system? And the company that I was working with or working for at that point said that they were really customer focused or even obsessed. So this was a very, I think, almost obvious question, but they weren't really able to answer that question. So I kept asking that question, and at the end, they said, okay, so we are going to change the strategy. We are going to implement new features. In that case, the feature was to provide more different products, a greater variety of products to the customer, and make that the goal of the migration. So instead of just mechanically migrating every piece of the system, they would build new features. And that means they provide more value to the customer, to their users, and more motivation. And that was, I believe, asking that question was probably the most valuable thing that I did in my consulting gig there, and insisting on an answer. A different example is, again, a stepwise migration to microservices by the book. And the original plan in that case was to provide no business value whatsoever, which turned out to be frustrating. And it turned out that the users of that system struggled with reporting. The reporting was really broken, and they had to run the reports over and over again to get more up-to-date results and so on. So that was really a problem. So they started the migration project, changed strategy, and decided to implement new reporting first, which they would probably never had done otherwise. And that changed the whole project to more motivation for teams and business experts. This example is a great example because there's actually a paper written about it. And I did an episode about that paper, about the Strangler fig pattern. And if you go to that website of that episode, I'm doing a stream every Friday in German, I'm afraid. So the episode will be in German too. But if you go to the website, you will find a link to the original paper that's in English. And one thing that I just want to point out is that this is the Strangler fig pattern, and it's not the Strangler pattern. So it's not some person strangling another person. It's actually, as you can see here in the thumbnail, it's actually a plant that grows in with a tree. So it starts growing somewhere in the tree higher up, and then grows up to get more light and grows down to get access to water and soil. And and eventually it might even kill the tree, because then the tree would be fully covered in that Strangler fig. But that's not the original goal. And so the metaphor is not strangling the application, but rather what the Strangler fig does. Domain-driven design. I did a talk here also about domain-driven design, and I said that, the domain should drive the design. That is one of the most important things that I think we should take away from domain-driven design, and that's also the reason why I think domain-driven design is a great name for that technique. So we should also let the domain drive the migration. So we need to figure out where the business value is for the migration. And if you do it this way, if you have a clear plan to provide some business value, it means that you have more motivation for everyone, not just the developers, but also the business experts and the users to support the migration. And the questions that you might ask to understand the business value is, so why are we migrating the system? There is a different question that I think is even more useful, which is, why are we migrating the system right now? Why are we not migrating the system in a year or not a year ago? And if you ask those questions, you get a better idea about what the driver of the migration is. And maybe there are ways to support those drivers even better. And in a goal like, okay, we need to make that system changeable. If that's the only goal, that doesn't say why it should be migrated right now. So there has to be some reason why it's being done right now. And just to, clean up the mess, that's probably not enough to start the migration right away at this point in time. So that is why I like that question. And actually, migrating a system might be an effect of a business strategy. So if you take that point and think about that a little bit more, it basically means the real problem is not trying to migrate the system, but the real problem is that there's some shift in how the business operates. And we might need to understand that fully. But I consider myself an architecture consultant. I don't really consider myself a business consultant, so I'm actually not sure whether this is what I should be focusing on. I think it's a good point of view, but still, I'm not sure whether that's something that I should focus on. Nick Tune considers this as a strategic approach. And for example, he has things like the business model canvas to capture changes to the business model, figure out how the business model will change, and then translate that into some strategy to also change the system, the software system, and to figure out the drivers there. I did an episode about that in German. Again, there is a paper that is linked there that you can read in English, obviously. And also, Nick is working on a book right now that is called Architecture Modernization, and that book really drives that point home that an architecture modernization is really driven by the modernization of the business case. And that's in the early access program. So you can take a look and see what Nick is up to. Legacy migration should not create new legacy. And that's probably one of the problems that I had with that initial large project that I've been part of. And here is finally the picture of that strangler fig. So it starts to grow somewhere and it grows upwards for light. It takes energy from the tree, and the intent is not to kill the tree. If you look at the picture more closely, you can actually see that this is the strangler fig. And inside there used to be a tree, and there isn't anymore. But that was never the intention of the strangler fig. The intention of the strangler fig was just to grow. And I think that's a good metaphor for what we need to do concerning legacy system. The idea is not to kill off the legacy system. The idea is to provide business value and to grow. And that is what we need to figure out. And what we can also take from that metaphor is to start the migration somewhere. As I said, the strangler fig would start to grow somewhere up here, maybe. We can take stuff from the original system, much as the strangler fig takes, energy from the original tree. One way to do that is event capture. So if there is something happens in the original system, we can get an event in the new system and work on that. Or asset capture, which means that we take some part of the customers or the accounts or whatever it is, or some parts of the products, and take over control for those. And then we grow. And as I said, the intent is probably not to kill the legacy application, but rather to provide value while you're creating that new system. The advantage that you have is that you know the existing architecture. And as I said, software development is learning. So the question becomes, does that migration actually improve the architecture? And there might be some reasons to do a fresh start instead. If you do a fresh start, then I would urge you to do what I've also presented in the last presentation, to structure functionalities. So here are some functionalities. We take the first one, which is invoicing. And now we basically said that there is a module here that is dealing with invoicing. So that's some functionality. And now we can have a discussion whether handling taxes should be in the same module. And I decided that it should be. And of course, you can come to other conclusions. That's not the point. The point is that we are structuring functionalities. So next one would be tracking. And tracking, I think, is very, very different from invoicing. So it's a very different functionality. It talks about where the delivery is, and that's a very different thing from, providing the invoice. So I would argue that it's pretty clear it should be a separate module. Then we have the shopping cart. Again, that's probably something where it's pretty clear that it should be some different module. Then we have delivery, which you can structure together with tracking. So then we have the question, where is the stuff that's tracking and how should it be sent to the customer? That's delivery, those 2 points in one module. And you can make a case, I think, for those to belong together. And finally, accept order, which is something that we put to the shopping cart. So then we have the invoicing process, shipping, and the order process, and we are basically done. We have relatively small models. And if we have some requests, so if we want to get an invoice, that's going to be in here. So as a user, for one functionality, you would probably just ask one system. And if there is some change to a functionality, it would again just be a change to one bounded context. And that's by design because we structured the system by functionalities. And we will have a product here. So we will have a product with price in the invoicing. We will have a product with size and weight in shipping. We will have a product with a description in the order process. And probably we will also have a customer. So we will have the customer with his billing address in the invoicing, with the shipping address in shipping, and with recommendations in the order process. And those might even be different customers. So if I order some stuff, and then the customer would be me, so it should be sent to my place here in Kaiserslautern, where I live. But the billing address might be Swaglab in Hamburg, and even the customer might be Swaglab. So then we do have two different customers for the same order. If you talk about the invoicing, it's Swaglab GmbH in Hamburg. If we talk about shipping, it's Eberhard in Kaiserslautern. Now, an approach to do a migration is to implement a requirement and then do some migration to that ideal modules that we've just seen. And then we do the next requirement and we do again a step towards that final architecture. And then we do the next step and so on and so on. So let's imagine that we have an existing system. And the existing system says we have an invoicing and order process that should be separated at one point. That's what the goal says. But they are really together in one system. That's the legacy. We have a shipping system. That's, again, legacy. And then we have a product information system and a customer information system. That's all the legacy stuff. And now we build some reporting and we build the new order process. And as I mentioned before, in here, we would probably like to have separate models for things like the product and the customer. And eventually, we would like to get rid of that product information system or the customer information system. But it's probably not wise to do that as a first step. So what we will probably do is we will probably do a replica of some data. So in here, we would have, I don't know, reporting concerning the orders from here. And here in the order process, we would have the replica of the product and customer data that we need for the order process. The reason why I would rather replicate the data is because then there's more independence. So that replica here can be extended to include information that is specific to the order process. And then that large complex model over here doesn't need to be touched. Instead, you have a local model that you can adjust to your specific needs in the order process. Now, if we do this, the question is whether this is better or worse than the original architecture. I'm just going to go back to that slide for a moment. So the original architecture was the green architecture. The new architecture is the green plus the pink stuff and or purple. And if you think about it, well, reporting is a new additional part. There are more dependencies to legacy because we have all that replication of data. So it's probably worse. The order process is probably better structured than the old order process, but the old order process is still around. So actually, the complexity of the system increased, right? Because we have just more stuff. We didn't manage to get rid of any of the original stuff. So you can make a point to say that this architecture is actually worse than the original architecture. But really, how important is that goal? We did not really manage to get near it, so we didn't have any easier architecture so far. And I'm not sure why that final architecture is so important. So we figured out that final architecture with those three bounding contexts: shipping, invoicing, and delivery. Um, but we didn't manage to get near it. Um, what does matter is what you can actually achieve, and that we did provide some business features. So I came across this building in Schleswig, that's a rather smallish town at the very north of Germany. And this is quite an old building, as you can see. And I took a picture of that, actually quite a few pictures, because I thought it was interesting to see how a building that is 800 years old changed over time. And as you can see, they did quite a few things here, right? I mean, it's really easy to tell that they changed a lot. And that's because it used to be a monastery originally, then it was a home for the poor, and now it's part of the town hall. So the requirements changed a lot. And this building is not aesthetically pleasing. You could argue that it became more complex, but it fits its purpose. And therefore, I think it's not, you can argue about whether it's a beautiful architecture, but it fits the purpose. And I think this is very similar to what we just saw with that software architecture. So when I take a look at these problems, my gut feeling is that it's comparable to some person who wants to climb that peak over here. And that would be, the project goal. So it's a metaphor for the project goal. It's the successful migration to a great modularized system. And what we are looking for is some map, some clear way to get to that goal. But in my opinion, the real problem is how do we manage to get over the next obstacle? So there might be, there might be some river, and you need to cross that river, or the way that you originally intended to walk or to hike is closed off, as it happened to me. So what do you do now? And these are the current requirements that we have in the migration. So it's important to take care about those requirements and to somehow fulfill them. And then we need to figure out what the next step is. So how can we implement the current requirements and somehow still approach the goal? And sticking to that metaphor, I think it makes a lot of sense to not ignore the project goal and the migration. So that original um, architecture plan, the original intended architecture, that's still important. Much like you would, look up and say, okay, this is the peak that I want to go to, but you need to focus on the next step and figure out where to go to. And this is often forgotten. I somehow believe, or that's what I feel with most of my consulting gigs, that people say, okay, this is the architecture, this is what we need to figure out how the final system should look like, and then somehow we will manage to migrate that system. And I think it's quite the opposite way around. So the most important problem is what value will you generate in the next few months? How will you be able to deal with that migration? Um, and there is also another thing that I just want to point out. So some of the parts, some parts of the system might be beyond repair. You might not want to invest in them anymore. So you can isolate them and just let them be. And this is what Big Ball of Mud says. And there is a pattern in the original paper about Big Ball of Mud that is called sweeping it under the rug. And then you just don't see it anymore and it's closed off. And I think that's one of the ways to handle legacy systems. Again, I did an episode about that. You will find again in German, I'm afraid. Sorry about that. But there is a link to the original paper, and I would really urge you to read that paper. So you probably need to compromise during migration. You might need to do some migration steps that cannot be motivated by business value. What I'm trying to say here is, so okay, at one point you might say, this architecture that we have right now, it's much too complex. We need to clean it up. But we can't justify that cleaning by implementing new requirements. So instead of implementing new requirements and taking a migration step, we just take a pure migration step that cleans up the architecture, and then we continue and do another requirement and another migration step. So that's how you can deal with these kinds of problems. There's also another point. So is migration actually the only option to improve? And the advantage that we have with the legacy system is that we know the existing system and its environment. And usually there are quite a lot of challenges. So there are many options to improve the situation. So there is a lot of choice how you can clean up things and what you can do. So let me give you an example. So this is again a consulting gig, and we talked about how you can migrate to microservices. And the reason why they wanted to do that is because they wanted to decouple teams. And that means a lot of effort because you change all of the architecture and you need to do a very fundamental shift in the architecture. And that takes some time. And unless you actually did that change, you won't get a lot of benefits. So we looked for some alternatives. And one of the problems, the real problem why those teams were so strongly coupled was because they could just deliver so often every day. So they competed for spots in the continuous delivery pipeline to actually deliver or deploy their changes. So one of the alternatives is to improve the continuous delivery pipeline and just speed it up. And if you're lucky, that's much easier than a fundamental architecture shift. So knowing those different options and tackling and using them, I think that's another thing that you need to be aware of and that you need to figure out. So in conclusion, legacy means we know a lot of stuff and we can use it to our advantage. We should provide business value during the migration, so let the domain drive the design. If you're interested and want me to talk to you about your specific problem, we provide some easy startup consulting, 60 minutes consulting. We do that online. It includes a report. It's moderately priced at 99 euros, and you can just book a slot online with me or my colleagues. If you enjoyed the presentation, here is an email address, and this is the link to the OneDrive where you can download the slides, my free booklets and sample chapters from my other books. This is, if you use the email address, that's going to be handled by an Amazon Lambda script, and therefore your email address will be locked for 14 days. That's the minimum that I can set up. And if you made any mistake in the email address, I would handle it myself. So that's the data privacy note. Thanks a lot for listening. I believe we still have a few minutes for questions, so I'm really eager to see what questions you might have. So you can either ask in the chat or here in person if you unmute yourself. And this is also the link to the material, so you can just download the material on that OneDrive.